In this video, we'll be going through the multiple choice questions from the 2024 Mathematics Extension 2 HSC exam. Question 1. Which of the following vectors is perpendicular to 3i plus 2j minus 5k? So the approach for this question is to simply check each of the options by taking the dot product with the vector in the question and seeing if it's equal to 0. We know that two vectors are perpendicular if their dot product is equal to 0, and so we're just manually checking each one here. And we can do that pretty quickly in our heads. So the dot product here would be minus 3, minus 2, minus 5, clearly not 0. Here we would get 3 plus 2 plus 5, also not 0. And then we're going to get minus 5 plus 5 minus 5, not 0. Of course, it's going to end up being the last one. So we'll get, let's see, 9 minus 4 minus 5, and that is equal to 0. So these two dot to equal to 0, and our option D is correct. Question 2. Consider the following statement written in the formal language of proof. And then it presents us with this thing. And it asks which of the following best represents this statement. Okay. So a bit of exam technique would be to look through these options here and see where each of the options differ. So they're all talking about sine theta equal to minus cos phi. So that's really not going to be the thing that determines which is correct. Where they change is with the quantifiers. Okay, so this is for all theta, and this is there exists a phi. So it starts off for all theta, and then this interval pi on 2 to pi, that's the range of values in the second quadrant. So I can read this as for all theta in the second quadrant, there exists a phi, and this interval here is the third quadrant, so there exists a phi in the third quadrant, such that sine theta equals minus cos phi. So it's for all theta in the second quadrant, and that looks like that option there. There exists a phi in the third quadrant, so option C. Question 3. Consider the statement, if a polygon is a square, then it is a rectangle. Which of the following is the converse of the statement? So if I have an implication, P implies Q, the converse of that is Q implies P. So I'm literally just swapping these two parts of my implication. So here I've got if a polygon is a square, then it is a rectangle. The converse is going to be if the polygon is a rectangle, then it is a square. Okay, that looks like option A. If the polygon is a rectangle, then it is a square. Question 4. A monic polynomial f of x of degree 3 with real coefficients has 3 and 2 plus I as two of its roots. Which of the following could be f of x? Now, this is a question where we're told that there are real coefficients, and as soon as I see a polynomial with real coefficients, the very first thing I'm thinking about is the conjugate root theorem, which says that any complex root of a polynomial with real coefficients has to have its complex conjugate appearing as a root as well. So if 2 plus I is a root, then I know that 2 minus I is also a root. And so I've got now the three roots of the equation. 3, 2 plus I, and 2 minus I. So I need to determine which of these options is f of x, or could be f of x. So the way I'm going to approach this is by using the sum and product of roots. So I can see that the sum of roots is going to be equal to minus b on a. But I know it's monic, so a is equal to 1. So I've got minus b divided by 1. And what's the sum? The sum is the sum of these guys. So 3 plus 2 plus I plus 2 minus I. Those i's are going to cancel each other out, and we get 7 equals minus b, or b equals minus 7. Then I'm going to, well, now that I have b equal to minus 7, I can cancel off options C and D, and I just have to determine whether it's A or B. And an easy way to do that is by checking the product, because that will distinguish whether it's plus 15 or minus 15. And so the product, that's going to be equal to minus D on A. Again, A is equal to 1, so this is minus D. The product is 3, 2 plus I, 2 minus I. This is quite nice because we have conjugates. Multiplying conjugates is easy. That'll be 5 times 3 is 15. So D is negative 15. And if d is negative 15, that gives us option B. So we'll circle option B. Question 5. A particle is moving in simple harmonic motion with a period 10 seconds and an amplitude of 8 meters. The particle starts at the central point of motion and is initially moving to the left with a speed of v meters per second, where v is positive. What will be the position and velocity of the particle after 7.5 seconds? Okay, so I'm going to draw a little diagram up. This can be our center of motion, roughly. Oh, it's not that accurate. If I move this over a bit, that's a bit better. And then these are going to be our extreme points here. And let's try to track what the particle is doing. It's starting from the center, and then it travels to the left. Now I know that it has a period of 10 seconds. So it travels like this, all the way back to the other side, and then back to the center, and that takes us 10 seconds in total. Now, because of the symmetry of this problem, I can see that this here is a quarter of the trip. That little section there is another quarter of the trip. That section there, whoop, that's a bad arrow. That section there is a quarter of the trip, and then it would take another quarter of the trip to get back here. So I can divide each of those sections up into 4 parts. That's each quarter of the trip. And it just so happens that the numbers have been made nice in this question, that 7.5 seconds is 3/4 of my total period. So this will take me 2.5 seconds. Then to get here, another 2.5 seconds. Then to get here is another 2.5 seconds, and that takes me to a total of 7.5 seconds of traveling. So my particle ends up being at this point here. So it's 8 meters to the right of the central point, and it has a velocity of 0 because we know that at the extreme points, the particle in simple harmonic motion has a velocity of 0. So this is option D. Question 6. A light string passes over a smooth pulley. Attached to the ends of the string are masses of 9 kilograms and 5 kilograms as shown. The acceleration due to gravity is g meters per second squared. What is the acceleration of the 9 kilogram mass? Okay, so we have acceleration due to gravity downwards, and this system is going to go down because the 9 kilograms is heavier than the 5 kilograms. So I'm going to define this downwards as the positive direction of motion. So the sum of forces is MA, and I also have, actually I should have said earlier, I also have a tension force in my string going upwards. So mass times acceleration is the force due to gravity. Oops, let me use blue. The force due to gravity minus the tension force, so the force of tension. Okay, so mass is equal to 9. I have 9A equals, force due to gravity is mg, so 9g, minus my tension force, which I'm going to call T. So that's analyzing this particle, or this mass, I should say. How about this mass? It also has a tension force going up, and that's going to be the same. The tension is the same throughout the string. It has a force of gravity going down. Of course, it's going to be different because there's a different mass. And this particle is going upwards, so the positive direction of motion would be up. So this will be positive. So we do MA equals the tension force minus the force due to gravity. So 5 times acceleration equals the tension minus the force due to gravity is 5g. I have equation 1 and equation 2. I can add those together to get 14a equals, that's 4g. And I want the acceleration. So the acceleration I will get by dividing by 7, 2g on 7, option A for question 6. Okay, question 7. It is given that the modulus of z minus 1 plus I is equal to 2. Find the maximum possible value of the modulus of z. Okay, I can think of two ways to do this, and I'd like to show both because I think they're both quite nice. Firstly, we can do this using the triangle inequality. So, I'm just going to make a clever addition of 0. I like to call this trick adding 0, where you have the modulus of z, but I'd like to involve this minus 1 plus I, because I have information about the modulus of z minus 1 plus I. So what I'm going to do is I'm going to subtract 1 and then add I, but then I have to do the opposite. I'm going to have to add 1 and subtract I. And then I'll treat this as one entity, and I'll treat this as one entity. And now I'm going to use the triangle inequality, which says the modulus of z plus w is less than or equal to the modulus of z plus the modulus of w. Okay, so that's less than or equal to the modulus of z, modulus of z minus 1 plus I, plus the modulus of 1 minus I. Okay, now I know what this is. It's given to me in the question. That's equal to 2. So that's equal to 2. And I can work out the modulus of 1 minus I. That's just equal to root 2. And so my answer is going to be option C. Now, another way that this could have been done is graphically. So if I draw up the locus, or the region, or the curve represented by this condition, the modulus of z minus 1 plus I equals 2, I would firstly just rewrite it as z minus 1 minus I equal to 2, and I'd find the point 1 minus I. So I would go across 1 unit, go down 1 unit, and that's going to be the center of my circle. My circle will have a radius of 2. So let's try to draw something roughly approximating that. Yeah, maybe something like this. So this is going to be our locus. This is the point 1 minus I, and I know that I have a radius of 2 units. Now I would like to find the maximum possible value of z. So z is any point that lies around on this circle. And if I'm trying to maximize the modulus of z, I'm trying to maximize the distance away from the origin. And the furthest that could be is if I am at this point, which when I draw a line through the center, goes all the way to the end, to the edge of the circle. So it's at this point. Now I can work that out because I know that the distance from the origin to the center is the modulus of the center, so the modulus of 1 minus I. And then that remaining distance there is the radius, which is 2. So I've got 2 plus this distance, which is the modulus of 1 minus I. Well, I already worked out those values up here. It's 2 plus root 2. Okay, so that's another way that this question could be approached. Question 8. Now, question 8, I would like to put an asterisk next to that because I believe that this question is probably not in the syllabus. I think it's quite dodgy actually, and a little bit careless from the setters of the exam, because here we're dealing with complex powers where we have a non-zero real part. And this isn't really defined in the syllabus, and there's no reason to believe or to expect that our regular power rules apply when dealing with complex indices, really. So it is a little bit dodgy. However, I'm going to still do the question, and we're going to assume that they do work. But like I said, this is not something that anyone should expect or believe to work without proof or justification. Anyway, we want to work out which of the following is equal to e to the z bar, where z equals x plus iy, with x and y real numbers. Okay, so we have e to the z bar equals e to the x plus iy bar, which is e to the x minus iy. I can break this up, and this is where I would say it's potentially dodgy. But e to the negative iy, that's the conjugate of e to the iy. But e to the x is a real number. And I know that the conjugate of any real number is that same real number. So e to the x is equal to e to the x bar. I know that the product of the conjugates is the conjugate of the product. And then I'm going to use my indice laws, assuming that they work for complex numbers. And I end up with the conjugate of e to the z, which is option A. Okay, next question. Consider the solutions to the equation z to the 4 equals -9. What is the product of all of the solutions that have a positive principal argument? Okay, well, z to the 4 equals -9. I'm going to write that as 9 times e to the I pi. But because I'm about to take the fourth root, I'm going to write this as pi plus 2k pi for integer values of k. What integer values am I going to take? It's going to be 0, -1, +1, and -2. And I take this choice in this order, going from 0, -1, +1, -2, and then if I would continue, it would be +2, -3, +3. Taking the negative first, because that's going to give me ranges of my argument within the principal argument. Okay, so if I substitute those in, or actually first I need to take the fourth root. So the fourth root of 9 is the square root of 3. So this is e to the I pi plus 2k pi on not 3, on 4. And that's for these values of k. Let's start subbing in the values. So I have root 3 e to the I pi on 4. Root 3 e to the minus I pi on 4. Now I sub in +1, root 3 e to the I 3 pi on 4. And root 3 e to the minus I 3 pi on 4. Now I want to multiply the solutions with a positive principal argument, which are these two. So when I multiply those together, I get root 3 times root 3, e to the I pi on 4 plus 3 pi on 4. That'll be 3 e to the I pi, or -3, option B. Question 10. 3 unit vectors A, B, and C in 3 dimensions are chosen so that A is perpendicular to B, B is perpendicular to C, and the angle theta between A and A plus B plus C is as small as possible. What is the value of cos theta? Okay, so I've got some information here. I've been told that A is perpendicular to B, which means their dot product is 0. Likewise for B and C. Now, I want to find some information about cos theta. So the best way to go about introducing the angle, or cos theta, in a vector question is to use the dot product. So I know that I'm taking the dot product of these two because I'm looking at the angle between those two. So it's A dotted with A plus B plus C. That's equal to the length of A times the length of A plus B plus C times cos of the angle between them, which is theta. Now, I'm going to expand out the left-hand side. I'll get A dot A plus A dot B plus A dot C. On the right-hand side, I have the length of A. Now, I forgot to mention this, but we also have information about A, B, and C in that they're unit vectors. So I also know that the length of A equals the length of B equals the length of C equals 1. So this is going to be 1 times the length of A plus B plus C cos theta. Okay, now I've been told that A dot B equals 0, so that's going to disappear. A dot A is the length of A squared, and the length of A is 1. So this becomes 1, this becomes 0. I don't have any information about a dot c at the moment. So far my simplifying has got me down to 1 plus a dot c. And then I'm just going to divide by the length of a plus b plus c. And so I have an expression for cos theta. But I need to do a little bit more work. I have to try to manipulate this length of a plus b plus c. And if I'm having a look at what information I've been given, well, I've been given this and this. But I've only used the length of a equal to 1, and I've only used a dot b equal to 0. They wouldn't give me this other information about b dot c being equal to 0 and these being unit vectors if they weren't necessary. So what I'm going to do now is I'm going to have a look at what I can do with a plus b plus c. I have the length of this thing, but the length by itself is a bit hard to work with. However, if I take the square of that, well, I know that the square of any vector is the vector dotted with itself. So it's going to be a plus b plus c dotted with a plus b plus c. Now, if this was a short answer question where you're getting marked for your working out, I would recommend and advise that you show this expansion and not just jump straight to the answer. But since this is multiple choice, this is one that's really useful to be familiar with. This is going to be equal to the length of a squared plus the length of b squared plus the length of c squared plus 2 times the dot products taken 2 at a time. B dot c. Okay, so now that I've done this expansion, you can see that I'm able to use the fact that all of these are unit vectors. So this will become 1 plus 1 plus 1, which is 3. Whoops. Here I'll be able to use the fact that a dot b is 0 and b dot c is 0. And I'm left with just 2 a dot c. So plus 2a dot c. And so therefore this length is the square root of 3 plus 2a dot c. Now I'm going to substitute that back in for my expression for cos theta. So I've got cos theta is equal to 1 plus a dot c divided by the square root of 3 plus 2 times a dot c. And now what I need to do is, well, I need to see what the question's asking for. Well, it's told me that this angle theta has been made as small as possible, and I want to find the value of cos theta. So, if theta has been made as small as possible, what I need to do is I need to think about, well, this is going to produce, for different values of a dot c, this is going to produce a constant that cos theta is equal to. So here I can really say cos theta is equal to k. Okay, I can say cos theta is equal to k, and k is going to change depending on a dot c. Eventually, I want to find theta by itself, so I have to take the inverse cos of both sides, and I have inverse cos of k. Now, because inverse cos is a decreasing function, if you think about what it looks like, inverse cos looks something roughly like that. It's a decreasing function. If I want to minimize my value of theta, I have to try to maximize my value of k. So the larger the value of k, the smaller the value of theta. So, if I'm able to find a value of a dot c which produces the largest value here, then I know that that's going to produce the smallest value of theta. Because this would be larger, whichever one it is, would be larger than all of the others, and so it produces a smaller value of theta. And I can do that because if I think if a dot c is equal to 1, what happens? I get 1 plus 1 over the square root of 3 plus 2, which is 2 on root 5. So if a dot c is equal to 1, which it certainly could be, there's no reason why it can't be. If a dot c is equal to 1, I have that cos theta equals 2 on root 5. And 2 on root 5 is larger than these other options here. And this is something that you just check by calculator. So I found a value of a dot c which produced amongst these 4 options at least, the largest value of cos theta. And so that value of cos theta is going to produce the smallest value of theta. And so option D will be my answer. And that's the end of the multiple choice.